Welcome everybody to our fifth listening sessions. As you know, today the subject is to be the microform from the granular perspective to a macro perspective of the sound material. To begin, let's say just 2 or 3 words about granular synthesis, really, in a very small nutshell. Well, what is granular synthesis? The idea behind granular synthesis is that is a sound manipulation technique from sound grains. It means very short slices of sound that we change in pitch, we change in duration, and we change the speed to create sound textures. In granular synthesis, in fact, we spend a lot of time just controlling all the parameters of the grains. Usually, we have a parameter for each grain, like the duration, the amplitude envelope, the treatment, the transposition, frequency shift, and etc. But also all the parameters for the texture, static or dynamic. That means the grain density, the grain rhythm. In granular synthesis, we can have what is called synchronous or asynchronous granular synthesis. Synchronous, that just means that we have a kind of homogeneous tempo or time. And anyway, nowadays, what we call granular synthesis is turning in what we can call concatenative sound synthesis. And as was defined by Dimo Schwartz in his dissertation, what is concatenative synthesis? It's a kind of sound granular synthesis where we use large bases of sounds that are segmented in unities. And most important, we have very nice selection algorithms to match the grains that you want. But we can't speak about a synthesis technique without saying that always or most part or usually, behind a synthesis technique, you have an analytic point of view. In the case of granular synthesis, it came in 1946, that thanks to the physicist and Nobel Prize winner Dennis Gabor. At this time, in the 40s, Dennis Gabor came up with a system that used grains to reproduce sound. He documents his finding and the mathematics to support it in a very well-known article called The Theory of Communication, which was followed up a year later with acoustical quanta and the theory of hearing, where he showed that we could see the sound from a granular point of view. Anyway, but from an aesthetic point of view, or musical point of view, some composers, thanks to the new instruments, began to work with the concept of small unities and textures outside the context of granular synthesis. One of them, one that you can say that is a precursor, was Hugh Caine. Hugh Caine, it's a Canadian electronic music pioneer and inventor. He designed over 20 analog musical instruments. One of them was the special purpose tape recorder. It was developed in the 50s. This device, primarily called the multitrack, allowed to play 6 tapes simultaneously, changing the playback speed of each tape independently and recombining the result sound into a single record, all controlled, as you see, by a musical keyboard. This was a device more focused on composition. Using this device, Hugh Caine created Dripsody from a single drop of water. Dripsody was composed in a night of 1955 as a kind of water drop rhapsody. All the musical material is derived from transformation, speed change, of the original sound with a special purpose recorder. And as you can imagine, the main material is just this single water drop. It's actually one of the classics of the tape music. The visualizations that we are going to see comes from Michael Gatt's Dripsody analysis that you can find in the OREMA project from the Montfort University. What I propose to you now is to take a look or to listen Dripsody. In this representation, as you can see, we have in the bottom the spectrogram. Here it's the representation or the acousmography that did Michael Gatz, and up in the upper part you have the structure, the main structure of Dripsody. The structure of Dripsody can be seen as a 6-section piece with one introduction where you have the dropping water theme, 4 variation, and a coda in 2 parts, where the piece winds down by reducing the number of tracks to a single drip. What I suggest to you now is just to listen. It's a very short piece. Oops. Yes, you can see that it's a tape music with a lot of humor. And just to remember that Hugh Caine was a very pretty good pianist. The next piece, it's an electroacoustic classic that is the well-known Concret pH. Concret pH from Iannis Xenakis. It's a textural composition. We can say a kind of moving or immoving cloud. Iannis Xenakis composed Concret pH in 1958 at the Groupe de Recherche Musicale, in the Groupe de Recherche Musicale Studios in Paris. As is well known, this piece was conceived as an introductory event in the Le Corbusier Philips Pavilion, presented at the Brussels World Fair in 1958, as you may be seen in the presentation of Pierre Coupry. Do not forget that in the Pavillon Philips at Brussels also includes the Varese only tape work Poème électronique. As pointed out by Makis Solomos, Xenakis had a real interest on Denis Gabor theories, and he even exposed the granular paradigm as a basic hypothesis for his work in the 60s, based on the work of Denis Gabor. It's a quotation from Xenakis, and you can see that what he says is all sounds represent an integration of corpuscles of elementary acoustic particles, a kind of sound quanta. For Concret pH, The main material was recordings of burning wood embers cut into 1-second fragments. The main techniques employed in concrete pH was the splicing of numerous bits of magnetic tape, speed change, and mixing to obtain varying densities. Something that is quite important, this work was not the result of mathematical operations, but was approached by the composer intuitively in the manner of a sound sculpture. Concrete pH, it's a really very strange work. If you see just the spectrogram, you have something that is quite static, but you have something that it's static in the registers, more or less, but you can see that what changes is the density and the movement inside the cloud. To listen concrete pH, what I suggest to you is to follow it with the representation that I just showing a little bit here, is not exact. This kind of representation, where what we are seeing here is this form. The middle of this form is the brightness, the spectral centroid. The weight of this form here, it's the spectral standard deviation, and the color, in this case, is the perceptual spectral variation. That means you can say that the color in this curve here follows more or less the movement of the grains in the sound. Very difficult piece. Just don't forget that all the sounds comes from burning wood embers. The next piece I would like to just to show an extract, not all, is Analogique B. A year after Concret PH, Xenakis tried working more systematically with sound grains and composed analogic B. Analogic B consists of granular sounds produced by recording just sine tones emitted by analog tone generators onto analog tape, and then cutting the tones in the fragments and using Markov chain model to put it in time. In analogic B, Xenakis used really a mathematical model to compose, to put together all the sounds. The way he did it was to put this brief composition with another piece that is called Analogic A. Analogic A was a stochastically composed score for 2 violins, 2 cellos, and 2 contrabasses. You are going to see the way that Xenakis used Analogic B in the context of Analogic A remind us a lot Varese's Désert, where you have this kind of call response between the acoustic world and the electronic world. Don't be afraid, we are not going to listen all. Just section 2, where you have, this is the analogic A and B, all the piece, just the section 2, but preceded by section 1, where you have the acoustic instruments. When you really listen all the piece, you can can have the feeling that the granular synthesis responds to the orchestra by mimicking it. But in fact, the 2 words uses the same model of Markov, or the same matrix or the same matrices from the Markov models. That it's like if the 2 words uses the same basis to regenerate material. Just another example, it's the section 10, preceded by section 9. Just and so on. Okay, the next piece, it's Kontakte. And Kontakte, as you know, is an electronic music work by Karlheinz Stockhausen, realized in 1958 at the VDR studios in Cologne, with the assistance, this is quite important, of Gottfried Michael Koenig. It was premiered May 10th in 1960 at the Festival Concert for the International Society of Contemporary Music in Cologne. Something that is quite important about Kontakte, Kontakte has in fact 3 forms. We have what is the basic form, that is just the sounds, the electronic sounds alone. The second form, that it's the electronic part, the tape, more the piano and percussion, and a third part that was incorporated in a bigger work that is called Originale. We will now we will present this piece with more details in a further session. For now, I would like just to focus on some granular texture used by Stockhausen. In some sections of Kontakte, Stockhausen generated granular textures with sine pulses, very short sine pulses. We are just listening 3 of them. The first is in the first part, the first structure, at IC. It's what we see here, and it's short. You had also the piano, another one that is really short. Good. And the last one, at the end of the section 7, or the structure 7. Okay, cool. And you have an idea of the granular synthesis. But let's make a temporal jump. The next piece we are going to listen is the Barry Truax Riverrun that was composed in 1986 and was reworked until 2004. In fact, it's the first work of electroacoustic music that was entirely created using the first real-time granular synthesis software called GSX that was running on a very old PDP 111223 computer controlling a DMX 1000 digital signal processor. I look very geeked saying all of this, but anyway, I hope it makes sense. But more important is it's really the first electroacoustic piece that was used a digital software to make in real time. And this software was called GSX, and that was programmed by Barry Truax himself. Just before proceeding, I would like to mention that the main resources on Riverrun analysis I used and existed were especially a very nice paper of Mara Helmuths and the Michael Clarke, Frédéric Dufeu, and Peter Minning recent work. That I say that I would like also to thank them, that is Michael Clarke, Frédéric Dufeu, and Peter Manning, to allow me to present their work in avant-premiere before the distribution. In fact, we have this paper, and this paper it's about a simulation, a computer simulation about Riverrun, and they are going to distribute very, very shortly an application in Max where you can do again Riverrun by yourself with a very good analysis. But so to begin, the first thing that will be nice is to explain a little bit about the software, and nothing better than Barry Truax explaining himself about it.
I want to show you a brief demo of a program that was developed back in 1985-86 called GSX, which was short for Granular Synthesis with the DMX 1000. DMX 1000 is a digital signal processor that was microprogrammable. And in those days, it wasn't possible to go into this level of micro domain of sound, microsound as it's sometimes called, except in non-real time with lots of detailed calculations, lengthy calculations, that is to say. So the DMX 1000 being programmable meant that I could implement this method of synthesis by going to smaller and smaller units called grains and produce hundreds and thousands of them per second, because there were no granular synthesizers that were out there. It had to be done in software. And so I'm just going to start with a basic granular patch. First of all, you notice the vintage 1980s terminal here with a beautiful monochrome yellow on it. Obviously no graphics, and just simply keyboard commands. So when we start this up, it's going to call back a series of control parameters, because obviously you can't generate and specify every grain when there's hundreds or thousands of them per second. So you need control parameters. And to make it work in real time, then the control parameters had to be fairly powerful, but also very compact. So in fact, they're going to all fit on one line. So let's just start it. So there's a granular texture, and there are 20 separate streams of grains. Not that you're going to hear them. Maybe later I'll go down to a single stream, just as a demonstration. But it's the combination of grains being generated all the time according to some random parameters. So for instance, These are all sine wave grains right now, so that's why the texture is fairly mild. And each one of them has a frequency around 200 hertz, and there's only a small frequency range. So if I change the frequency range to 50 hertz, or 100, or 200, or 500, we start getting some very rich textures, even though these are just sine waves. And you might even be able to hear that there's a lot of those happening at each time. Or I could be changing the average frequency, low, 100 hertz, 50 hertz, 500 hertz, 2000 hertz, which is actually very piercing, so we won't do that. And so that's perhaps the most obvious example of the grain's parameters is frequency. Now, less obvious is duration, because these are in milliseconds, and at the micro sound level, then there are.
Okay, we are going to stop. Yes, we have a lot of, but you can have an idea what was this software at this time. For any one of you that use it to work with softwares nowadays like Super Collider, Pure Data, and Max, you can imagine the gap from this time to today. But also to see that granular synthesis is not so new synthesis techniques. Anyway, for Riverrun, before listening, Riverrun, it's a very easy piece from the structural point of view. It can be seen as a 5-section piece, and like you can hear, and each section, like is seen here, for example, this is the first one, each section, it's composed by layers, different layers. But each one of these layers itself is composed by other layers of granular synthesis, as you've seen. Just to give an idea what Barry Truax did, it's for composing each one of these main layers, he just recorded on tape textures like you saw, and after in the mixing process he built all the piece. Okay. Yes, what I propose to you is to listen we have a problem here. Okay. I propose you to listen the 2 first sections and to notice 2 or 3 things that are very, very funny. You are going to have some shadows. We are just going to see this section and this one. What I suggest you to try to listen the parameters in some ways. That means the densities, how they evolve, the register of frequencies. But you have, in all the sections, you have these shadows here. I don't know if you guess what are these shadows. In fact, it's the kind of aliasing, because with the very low sample rate they use it at this time, they try to calculate frequencies that their system was unable to represent. It's a kind of fold-over frequencies here. Anyway, just listen these two sequences here. stop. I was making the 2 sessions, but the time is running. Maybe just to stop now. Just to make a remark, you can see that granular synthesis is a very nice technique to making interpolations or transitions between sound textures. Let's go ahead. Now concerning the macroform, or how composers try to sculpt the sound at another level. The last piece that we are presenting is Mycenae Alpha by Xenakis. Is the first piece entirely composed on the U peak. This work was specifically conceived to be integrated in the polytope of Mycenae, which was performed between September 2 and 5 in 1978 in the ruins of Acropolis of Mycenae in Greece. Anyway, maybe you are wondering what is the UPIC? The UPIC means Unité Pédagogique d'Informatique du CEMAMU. CEMAMU was the Centre de Mathématiques et Musique from Iannis Xenakis. In fact, just to put it simply, the UPIC was a computer complex system to allow composers to work with sound, drawing on them on a tablet in a very straightforward way, as you can see in the next pictures. And this is just a kind of sketch from Xenakis from this time. With a duration of 9 minutes and 36 seconds, the work consists, in fact, of 10 UPIC pages, like you can see here, drawn by the composer. This score that you are seeing, it's in fact comes from a paper from Xenakis in the perspective of new music. As you can easily notice in the score, you can see that one page is repeated, in fact are the pages 7 and 30 that are the same, just time scaled differently. As we don't have really too much time, what I propose is we are going just to see from section 6 to the end now. Oops. is all. Thank you. If you have any questions, you are stuck it. Good. Oh, yes.
I'm going to ask what was generating the sound in that last piece.
In this piece?
The graphical interface.
Yeah, just to come back to the UPIC. This is the UPIC. The UPIC was really a graphic interface where it's a kind of, in French you say c'est une table d'ingénieur, yes, where you could draw. And was a kind of space-time frequency, okay? But when each time you choose a frequency, it's not always just a sine wave. Could be a very complicated sine wave, a square, and anything else. It's why you have, you can see, in some moments, even if you have just a line here, for example, like just to try to come, oh yeah. You see that here, you have just a frequency, but you see that in fact you have an harmonic spectra. And was in this way you have this graphic interface after the computer interprets like a graphic time frequency, and after each frequency one is going to be played, it's assigned a kind of oscillator or a bank of oscillators. Okay. Yes?
And the oscillator is assigned children's random?
Oh, no. I don't have all the documentation here from the EPIC, but maybe another moment if you can write to me. I have a lot of stuff about it. No, because you had the, oops, in this way it's better. You have the interface to draw, but here you had a graphic display and control keyboard. And here you can just to choose. Now I am going to draw its square wave. And now you have an even a kind of random waves also. No, the waves was chosen here. Yes, the last one.
How is this granular synthesis?
No, this is not granular synthesis. This is macroform.
Ah, okay.
You slap it somewhere in the presentation.
Not
Yeah. Yes.
Can you define macroform?
Oh, thank you. It's just to revenge Frederic. I understand. When you speak macroform, yes. I was going to speak. The macroform, we can say that is the more high-level structure that you can find in one piece. You can say that the first structure that you have in the piece is the piece itself, where it begins, lasts, and ends. And it's what we speak at macroform. In the way I use it here, I use it in a very fuzzy way, I admit it. Because what I want to meant here, it's not, I am not more working at the level of the grain of the sound, but working, not me, but the composer, they work it more with the form of the sound. It's what I meant in this case. But macroform can have a lot of meanings, sure. Okay or not? Yes, net one.
What about granular synthesis in the 90s and 2000s, nowadays?
Yes, in fact, you have, in the 90s, you have a kind of revival of granular synthesis, especially with some softwares like Super Collider, Max, Pure Data, that make it very, very easy. Actually, I can say that because what Barry Truax did was very hard at this time, was very exceptional in some ways, and was very difficult. A lot of people worked, especially with C-Sound, but was at this time a non-real-time software. But after you, because the pieces I choose here was a kind of iconic pieces, fine, where the main process was granular synthesis. After granular synthesis is going to be used in the middle of the piece, like for example in the Kontakte you have just some moments where you have a granular synthesis. But the big revival is going to be in the 90s, end of the 90s, when it's beginning to be very, very easy. Actually, what Barry Truax did, it's really, I don't know, in 15 minutes you do it. I don't know, just some process, but even the piece. Wait the work of Michael Clarke, Frédéric Dufeu, and Peter Manning, because they have a wonderful paper explaining even for each part, for each layer, all the parameters. It's something very nice that is coming.
So nowadays it's basically the same technique, just more.
At the level, what we use actually like granular synthesis, it's exactly the same. The control is different. You see, for example, in a software like Kontakte, that is called concatenative synthesis, but you can say that concatenative synthesis is a kind of continuation of granular synthesis in some way. What changes is the way that you control, and you are going to choose the grains. Okay. What I propose, because it's maybe 3 minus 10 or 9, and a lot of you have a lot of stuff to do, but if you would like to speak more, coffee machine or somewhere the next days, okay? Have a nice afternoon. Thank you.